Hello everyone. Thanks for watching my video. In this video we will discuss about the life cycle assessment of semiconductors, mass production and extensive uses of semiconductors and how they contribute to global warming. Product information. Firstly, semiconductors are the brains of modern electronics. They are unique electrical properties that distinguish them from other materials. When it comes to electrical conductivity, a conductor is a substance that conducts electricity, and when it comes to electrical inconductivity, an insulator is a substance that does not conduct electricity. Semiconductors are substances with properties that fall midway in the middle of the spectrum. Silicon and germanium are two of the most common elemental semiconductors. Advances in semiconductor technology have resulted in increased system efficiency, miniaturization, and energy savings. There are two types of semiconductors. Intrinsic semiconductor. An intrinsic type of semiconductor material is made to be very pure chemically. It is made up of only a single type of element. It's a pure of metals such as silicon and germanium. Extrinsic semiconductor. The conductivity of semiconductors can be greatly improved by introducing a small number of suitable replacement atoms called impurities. Semiconductors were discovered in the 19th century, and they are still in use today. Transistors were first introduced in the 1940s. Radios, which had previously relied on vacuum tubes, were greatly reduced in size and became portable. Semiconductors are critical electronic components that let us go through our daily lives. They are highly conductive and carry almost no electricity, making them excellent conductors. Semiconductor devices are dependable enough to be used in devices that survive for 2 years or more. Among other things, semiconductors are critical in the management of equipment in a wide range of industries, such as maintaining a suitable room temperature with air conditioners, enhancing automotive safety, laser therapy and cutting-edge medical care and so on. In the life cycle assessment phase, we will discuss about the raw material extraction used for the manufacturing of semiconductors, the manufacturing process, distribution, usage and the end of life of semiconductors. Silicon, germanium, and gallium arsenide are the semiconductor materials that are most commonly utilized. Of the three materials, germanium was one of the first to be employed as a semiconductor material. Germanium atoms have 4 valence electrons, which are electrons that are placed on the atom's outermost shell. The conductivity of a semiconductor material is determined by the quantity of valence electrons present. Manufacture. The manufacturing of semiconductors involves logic design, mask design, fabrication, wafer probing and dicing, packaging and assembly, and final product testing. Silicon chips are made using a process known as chemical-mechanical polishing. This involves immersing the silicon wafers in abrasive chemicals to get the desired finish. Process involves layers of material stacked on top of one another to create a circuit. Pre-manufacturing stage. Melting and refinery. The silicon crystals are the predominant contributor to global warming. This is because much of the greenhouse gases are emitted during this process. Manufacturing stage involves assembly and packaging. It emits little air pollutants, wastewater and solid waste. Distribution. Chips are normally sliced and packed at a separate facility from the wafer manufacture location, which may be in a different nation or continent. Wafers are carried from the fab to an assembling factory, in which they are cut into die, packed into chips, and tested, and completed chips are then transferred to the site where they will be used. This means that semiconductor goods travel twice throughout the production process. Fuel and energy are required for every transferring. Usage. Semiconductors are used in a wide range of electronic devices, including mobile phones and digital cameras. They are also essential in the operation of ATMs, railway stations, the internet, communications, and other components of social infrastructure. In this way, semiconductors help us to live comfortable lives. End of life. In the end of life, EOL, ramifications of integrated circuit chips, semiconductors, lead emissions are the most evident. When the solder or wire bonding materials used to attach a chip to a board include lead, which is a neurotoxin that is harmful to people, lead emissions are generated. Let's talk about the impact throughout its life cycle. Raw material. The manufacturing of semiconductors requires a lot of environmental unfriendly resources, most of them rare earths metals. Manufacture. Workers and technicians working in semiconductor production are also at risk because of the wide range of chemicals used in the process. Distribution. A lot of fuel and energy is required to distribute semiconductors. Usage. The impacts of semiconductors during the usage varies during on the product. But semiconductors are used almost 24 hours a day. End of life, EOL. In the disposal phase, landfill or recycle, landfill of semiconductors produces little quantity of CO2. Life cycle evaluation of semiconductor goods is critical because of the scale and expansion of semiconductor production. There is still some recommendation that can be taken in order to achieve sustainability. Firstly, turning off our electrical appliances when not in use. Secondly, educating people about the need to understand the importance of semiconductors, use of power management. Thirdly, setting up power management software which the government should provide freely that minimizes the use of energy. Lastly, implantation of recycling programs, whereby semiconductors and all products that requires semiconductors in their manufacturing processes are recycled properly. This may include having a ministry that's in charge of recycling or sending used products back to the manufacturers. Thank you for watching my video. Please stay till the end of the video for the Q&A session.